Japanese pilots were shocked by America's P-38 Lightnings in the Solomons. October 15, 1942. Rabaul, New Britain. Lieutenant Commander Takeo Sato lifted the intelligence report from his desk, his lips curling into a practiced sneer. The afternoon light caught the gold braid of his uniform as he held the paper at arm's length, as if proximity might contaminate him with American incompetence. "Look at this," Sato said, flicking the document with his fingernail. "The Americans are deploying twin-engine fighters, twin engines on a fighter aircraft." Commander Akiro Nakamura, Air Operations Officer for the 11th Air Fleet, leaned forward and nodded his agreement. "Desperate improvisation. They lack the engineering precision to build proper single-engine fighters, so they bolt two engines onto an airframe and call it innovation." Lieutenant Koji Yamamoto, intelligence analyst attached to the 4th Air Army, straightened the reconnaissance photographs on the table, his expression troubled. "Commander, the specifications suggest unusual performance characteristics. The twin-boom design may provide advantages we should examine more carefully." But Sato waved him off with a dismissive gesture that had become habitual through 2 years of unbroken victories. "Yamamoto-san worries too much. We have destroyed the Americans at a ratio of 8-1 over the Philippines, 6-1 over Java, and 12-1 over Darwin. Our Zero pilots are the finest in the world, with an average of 400 combat hours each. The mathematics are undeniable. Japanese naval aviation is superior in training, equipment, and combat doctrine." What Sato didn't know, what none of them could have known as they reviewed intelligence reports in that comfortable headquarters, was that the P-38 Lightning would destroy Japanese air superiority in the Solomon Islands within 8 months. The numbers would become catastrophic. Kill ratios of 20-1, production numbers exceeding 6,500 aircraft, losses mounting to 300 pilots monthly. The confident dismissal in that Rabaul headquarters would become history's most expensive miscalculation, measured in 10,000 Japanese pilots dead. The confidence of victory at Pearl Harbor, the kill ratio had been infinite. 200 American aircraft destroyed on the ground, 29 Japanese losses. At the Battle of the Philippines, Japanese pilots achieved ratios of 8-1 in air combat. At the Java Sea engagement, Zero fighters destroyed 47 Allied aircraft while losing 6. At Darwin, Australia, Japanese Navy pilots shot down 12 Hurricanes and 3 Spitfires while losing a single Zero. The Mitsubishi A6M0 possessed a maximum speed of 331 miles per hour, a service ceiling of 33,000 feet, a range of 1,929 miles, and an armament of 2 20mm cannon plus 2 7.7 machine guns. The aircraft weighed 5,313 pounds empty, carried 470 pounds of armor and self-sealing fuel tanks. No, that is incorrect. The Zero carried 0 pounds of armor and featured non-sealed fuel tanks, a design philosophy emphasizing maneuverability over survivability. The aircraft could sustain a turn radius of 2,400 feet at combat speed, significantly tighter than any American fighter then in service. Japanese pilots trained for an average of 600 hours before combat deployment, compared to American pilot training programs that averaged 200 hours in early 1942. Recent American failures validated Japanese confidence. At Midway, American torpedo bomber squadrons had been annihilated, with VT-8 losing all 15 aircraft and VT-6 losing 10 of 14. The Grumman F-4F Wildcat, America's frontline carrier fighter, possessed a maximum speed of only 318 miles per hour and could not match the Zero's maneuverability in turning combat. The Brewster Buffalo, deployed to defend Singapore and Java, had proven catastrophically inferior, achieving kill ratios favoring Japanese pilots by margins of 5-1 or worse. The P-39 Airacobra, rushed to the Southwest Pacific, suffered from poor high-altitude performance due to its lack of turbocharging, making it vulnerable to Zero attacks initiated from superior altitude. Lieutenant Commander Sato's combat record seemed to confirm Japanese invincibility. He had personally shot down 11 Allied aircraft, 3 Hurricanes over Singapore, 4 P-40s over Java, 2 Buffaloes over Rangoon, and 2 Wildcats near Guadalcanal. His squadron had destroyed 93 enemy aircraft while losing 7 Zeros to combat and accidents. Sato had been awarded the Order of the Golden Kite and received personal commendation from Admiral Yamamoto. His tactical lectures at Rabaul emphasized aggressive pursuit, confidence in equipment superiority, and the psychological advantage Japanese pilots held over inadequately trained American aviators. Lieutenant Yamamoto's concerns, documented in intelligence reports that would survive the war, centered on American production capacity rather than current equipment quality. His October 1942 analysis noted that American aircraft production had reached 4,200 units monthly compared to Japanese production of 1,100 monthly. He calculated that even with superior kill ratios, attrition mathematics would eventually favor the Americans if production disparities continued. Yamamoto's report noted with particular concern that the Lockheed plant in Burbank, California, was expanding to produce a new twin-engine fighter at projected rates of 90 aircraft monthly. His superiors dismissed these warnings as defeatist speculation. Commander Nakamura, flying combat air patrol over Guadalcanal in early October, had engaged a flight of Wildcats and achieved 3 confirmed kills in a 4-minute engagement without sustaining damage to his Zero. The experience had reinforced his contempt for American fighter pilots and equipment. American aircraft seemed slow, their pilots predictable, their tactics unsophisticated. Nakamura's after-action report stated, "The enemy shows no improvement. They persist in attempting turning combat, which plays to our strengths. Their aircraft remain inferior in maneuverability and rate of climb." The mathematics seemed irrefutable. Burbank, California, June 1942. Kelly Johnson moved through the Lockheed Assembly Building where the third production P-38 Lightning of the day emerged from the final station. This single facility produced 12 aircraft daily. Every 8 hours, another twin-engine fighter rolled toward the flight line. In January 1941, America produced just 43 P-38 aircraft during the entire month, with production limited by manufacturing bottlenecks in turbocharger assembly and insufficient machine tool capacity. By December 1941, production reached 87 monthly as Lockheed streamlined assembly processes and subcontractors expanded component manufacturing. By June 1942, production accelerated to 250 monthly. By October 1942, the Burbank facility was producing 360 P-38s monthly. This single facility was producing more fighters than the entire Japanese Army Air Force received from all its manufacturers combined. Dorothy Miller, previously a seamstress at a Lowe's Angels dress factory, now operated a hydraulic press producing P-38 wing spar components at a rate of 42 units per 8-hour shift. She had received 3 weeks of training before beginning production work. Her station produced more complex aluminum assemblies in one shift than the entire Nakajima plant in Koizumi produced of comparable Zero components in 2 days. Miller earned $1.25 per hour, more than double her seamstress wages. She worked alongside 3 other women operating identical presses in a section that produced 168 wing components daily. The mathematics were simple. 4 women in Burbank outproduced 80 Japanese workers performing similar operations. Miller's supervisor noted that she rarely made errors, maintained consistent quality, and had suggested a tooling modification that reduced production time by 30 seconds per component. The suggestion had been implemented across all 4 presses within a week. In the Nakajima plant, such worker-initiated modifications would have required approval from 6 management levels and taken months to implement, if approved at all. Robert Washington, from Oakland, California, operated a specialized milling machine that produced engine mount forgings for P-38 fuselages at a rate of 24 units per shift. Washington had been trained as a machinist through a federal works program and hired by Lockheed in March 1942, despite initial resistance from some supervisors uncomfortable with integrated work crews. His single station's daily output of engine mounts exceeded the total production from the Army Air Arsenal at Takekawa, which supplied the entire Japanese Army Air Force with similar components at a rate of 90 monthly. Washington operated equipment that cost $12,000, more than the total capitalization of many small Japanese component suppliers. The machine could hold tolerances of 0.001 inches across complex 3-dimensional surfaces, precision that Japanese manufacturers achieved only through extensive hand finishing. Washington's production records showed he maintained 99.7% quality acceptance rates, while exceeding hourly quotas by an average of 8%. Charles Wilson, $1-a-year man from General Electric, managed turbocharger production coordination between General Electric's facility in Lynn, Massachusetts, and Lockheed's airframe production in Burbank. The turbocharger represented the P-38's critical technological advantage. It maintained engine power at high altitude, where Japanese fighters suffered performance degradation. General Electric produced turbochargers at a rate of 540 monthly by October 1942, each unit representing manufacturing complexity that Japanese industry could not replicate. The turbocharger required precision casting, specialized high-temperature alloys, and tolerance standards that exceeded Japanese manufacturing capabilities. Wilson's coordination ensured that turbocharger delivery matched airframe production schedules, preventing bottlenecks. Japanese aircraft manufacturers faced constant component shortages because their supplier network lacked such coordination. Americans discarded 4,200 pounds of aluminum scrapped daily at the Burbank plant from trimming operations and rejected components. Japanese industry allocated 3,800 pounds of aluminum monthly to the entire Nakajima Koizumi plant for zero production. The waste from a single American facility exceeded total Japanese allocation to a major production plant. The cafeteria waste from Lockheed's Burbank facility included 380 pounds of edible food daily that was composted or discarded, leftover sandwiches, partially eaten meals, excess preparation. Japanese aircrew at Rabaul received food rations totaling 2,100 calories daily, consisting primarily of rice, dried fish, and vegetables, with meat protein appearing once weekly. The Lockheed cafeteria served 4,500-calorie meals to workers who needed them, with beef, pork, or chicken daily, fresh vegetables, milk, eggs, and bread without restriction. Workers threw away food that Japanese pilots would have considered luxury rations. Workers threw away defective instrument panels that failed quality inspection at a rate of 12 units daily. Each panel contained 43 precision instruments including airspeed indicators, altimeters, artificial horizons, and engine monitoring gauges. Japanese pilots rationed instrument replacements because supply could not meet demand. Rabaul's maintenance depot received 17 replacement instruments monthly for the entire 11th Air Fleet's approximately 200 aircraft. The instruments Lockheed discarded daily would have supplied Rabaul's needs for 3 weeks. The waste from fuselage riveting operations produced 840 pounds of aluminum rivets weekly that failed quality inspection due to head deformation, length variance, or other defects outside tolerance specifications. These rivets were melted down and recycled, but the initial production represented waste from the standpoint of manufacturing efficiency. The Japanese Navy's Sasebo Air Arsenal received aluminum rivet allocations of 600 pounds monthly for all maintenance and repair operations across its responsibility area, which included approximately 300 aircraft. Lockheed's testing program expended 12,000 rounds of .50 caliber ammunition weekly in ground tests of gun installation, firing synchronization, and weapon systems validation. Japanese squadrons at Rabaul received ammunition allocations of 8,000 rounds of 20 cannon ammunition and 24,000 rounds of 7.7 machine gun ammunition monthly for all combat operations, training, and testing. A single week of American testing consumed ammunition equivalent to half of Japanese combat allocation. The single Burbank facility's electrical power consumption exceeded the total electrical capacity available to all Japanese aircraft manufacturing in the Tokyo-Yokohama industrial zone. Lockheed consumed 4.2 megawatts continuously, while Japanese manufacturers operated under power rationing that limited most facilities to night shift-only operation of power-intensive equipment. Lieutenant Yamamoto, reviewing intelligence reports about American production capacity, prepared an analysis that reached Commander Nakamura in October 1942. The report stated, American aircraft production now exceeds Japanese production by a factor of 4 to 1 and is accelerating. The Lockheed facility alone produces more fighters monthly than our entire Army Air Force receives from all sources. This production disparity will become strategically decisive regardless of current tactical advantages. We cannot trade aircraft at any ratio and sustain operations if America produces 4 aircraft for every one we produce. The mathematics are unfavorable. Nakamura filed the report without forwarding it to higher headquarters. Yamamoto's pessimism, Nakamura believed, undermined morale and ignored Japanese tactical superiority. November 2, 1942. 35,000 feet above Buna, New Guinea. 8:47 hours. Commander Nakamura was leading a sweep of 9 Zeros searching for American transport aircraft when he noticed sunlight glinting off aircraft at his altitude, 6,000 feet above the normal combat ceiling for American fighters. At 8:47 hours, he identified the silhouettes as twin-engine aircraft and assumed they were bombers separated from their formation. At 8:49 hours and 15 seconds, he initiated a diving attack from the Zero's superior position. At 8:49 hours and 42 seconds, the lead bomber, rolled inverted, split-test into a dive that Nakamura initially believed was an evasion attempt, then pulled up directly beneath Nakamura's flight with its nose coming up to firing position. At 8:50 hours and 8 seconds, Nakamura's wingman, Lieutenant Sato, exploded. The P-38's concentrated fire from 4.50 caliber machine guns and 120 cannon struck Sato's Zero in the wing root fuel tank. Elapsed time from engagement to destruction, 26 seconds. Kill time, 2 seconds of actual weapons fire. At 8:50 hours and 23 seconds, Nakamura's second element leader, Lieutenant Takahashi, attempted a head-on pass against another P-38. The American pilot did not evade. Instead, he maintained his heading and opened fire at 800 yards range. Takahashi's Zero disintegrated at 8:50 hours and 31 seconds, struck by approximately 60.50 caliber rounds and 820 shells that destroyed the engine, cockpit, and forward fuselage in a single sustained burst. Elapsed time from engagement to destruction, 8 seconds. Kill time, 1.4 seconds. At 8:51 hours and 12 seconds, Nakamura attempted to engage a P-38 in a turning fight, relying on the Zero's superior maneuverability. The P-38 did not turn. Instead, it accelerated away in level flight. Nakamura's Zero, at maximum speed of 331 miles per hour, could not pursue. The P-38 accelerated to approximately 390 miles per hour and simply departed the engagement. Nakamura watched it go, unable to catch it, unable to maneuver it into firing position, unable to force combat on terms favorable to Japanese tactics. At 8:52 hours and 47 seconds, Lieutenant Watanabe, flying Nakamura's port wing, was destroyed by a P-38 that had climbed above the Japanese formation, rolled inverted, and dived through with deflection shooting that struck Watanabe's Zero in the cockpit. Watanabe's aircraft fell out of control, trailing smoke. Elapsed time from engagement to destruction, 31 seconds. Kill time, less than 1 second of weapons fire. At 8:53 hours, Nakamura ordered his remaining aircraft to disengage. The P-38s pursued for approximately 1 minute, then broke off the chase and reformed. Nakamura counted his survivors, 5 Zeros from 9. The P-38s had destroyed 4 Japanese fighters without sustaining apparent damage to any American aircraft. Total engagement duration, 6 minutes 13 seconds. Enemy losses, 4 Zeros destroyed, 4 pilots killed. American losses, 0 aircraft, 0 pilots, possibly some minor damage that Nakamura could not observe from his position. Kill ratio, 4-0 in favor of American aircraft. The ammunition expended in this 6-minute engagement exceeded the monthly 20 cannon allocation for Rabaul's entire fighter complement of 57 Zeros. Nakamura returned to Rabaul at 10:15 hours and reported that his flight had encountered new American fighters with performance superior to expected parameters. His initial report estimated American aircraft speed at approximately 360 miles per hour, because he could not accept that the P-38 could reach nearly 400 miles per hour at altitude. His report noted that the American aircraft appeared to possess adequate armament, which significantly understated the reality that each P-38 carried 4 times the weight of fire of a Zero. Nakamura's report concluded that, with appropriate tactical modifications, the Zero can maintain superiority against this new aircraft. This assessment would prove catastrophically wrong. Denial, warning, and recognition intelligence dismissed the initial P-38 engagement reports as exaggerated combat stress responses. Lieutenant Commander Saito, reviewing Nakamura's report at Rabaul headquarters, noted that American fighters had never before demonstrated performance superiority over the Zero. He attributed the losses to pilot error, unfortunate circumstances, or possibly combat fatigue affecting Nakamura's squadron. Sato's analysis stated, "The reported performance characteristics are inconsistent with American design and manufacturing capabilities. American aircraft to date have proven inferior in speed, climb rate, and maneuverability. The reported losses likely resulted from tactical errors or mechanical failures rather than American equipment superiority. No fundamental change in combat doctrine is warranted." Lieutenant Yamamoto reported to headquarters with updated intelligence analysis based on multiple engagement reports, captured documents, and reconnaissance photographs. His November 1942 report stated, "The P-38 Lightning represents a fundamental shift in American fighter capability. Specifications indicate maximum speed of 395 miles per hour at 25,000 feet, service ceiling of 39,000 feet, and armament concentrated in the nose, consisting of 4.50 caliber machine guns and 120 cannon. The aircraft's twin-engine design provides redundancy that allows survival of damage that would destroy single-engine aircraft. The turbochargers maintain full power at altitudes where our aircraft suffer performance degradation. American production of this aircraft is currently approximately 300 monthly and accelerating. A single American factory produces more of these fighters than our entire Army Air Force receives of all fighter types. We are facing not just a new aircraft, but a production capacity that can overwhelm us through numbers even if we maintain tactical parity." American P-38 production in November 1942 reached 323 aircraft. Japanese production of all fighter types in November 1942 totaled 287 aircraft from all manufacturers including Mitsubishi, Nakajima, and Kawasaki. A single American facility exceeded Japanese industry's entire fighter output. By December 1942, P-38 production reached 341 aircraft. By February 1943, production achieved 385 aircraft monthly. By June 1943, production exceeded 400 monthly. They tried altitude advantage, positioning Zeros at 30,000 feet to dive on P-38 formations. The Americans climbed to 35,000 feet where Zeros struggled to operate and P-38s retained full performance. They attempted fighter sweeps, timed to catch P-38s during vulnerable moments of takeoff and landing. American radar installations provided sufficient warning that P-38s could climb to advantageous altitude before Japanese fighters arrived. They tried coordinated attacks using multiple Zeros to overwhelm individual P-38s through numerical superiority. American pilots refused to be separated from their formations and used superior speed to disengage from unfavorable situations. They attempted to lure P-38s into turning combat at low altitude where Zero maneuverability would dominate. American pilots declined to turn, instead using speed and climb rate to control engagement parameters. On November 18, 1942, a formation of 16 Zeros engaged 8 P-38s over Buna at 9:23 hours. The engagement lasted 14 minutes. At 9:23 hours, initial contact occurred at 28,000 feet. At 9:25 hours and 33 seconds, the first Zero fell, destroyed by a diving attack from above. Kill time, 41 seconds from initial engagement of that specific aircraft. At 9:27 hours and 12 seconds, 2 more Zeros were destroyed in a head-on pass where P-38 pilots demonstrated willingness to exchange fire at closing speeds exceeding 600 miles per hour. Kill time per aircraft, less than 2 seconds. At 9:29 hours and 8 seconds, another Zero was destroyed attempting to follow a P-38 in a climb to 32,000 feet. The Zero stalled at 29,000 feet, and the P-38 reversed and shot it while it was recovering. Kill time, 4 seconds. At 9:31 hours and 42 seconds, a Zero attempting to disengage was caught by a P-38 that pursued in level flight at 380 miles per hour, closed to 200 yards, and fired a 3-second burst that destroyed the Zero's engine. Kill time, 3 seconds. At 9:33 hours and 16 seconds, another Zero was destroyed in a similar pursuit engagement. Kill time, 2 seconds. At 9:37 hours, the surviving Zeros, now reduced to 10 from 16, disengaged successfully by diving to low altitude and using ground clutter to break contact. Enemy aircraft destroyed at 0925, 3310, kill time 41 seconds. At 0927, 12 Zeros, kill time under 2 seconds each. At 0929, 0810, kill time 4 seconds. At 0931, 4210, kill time 3 seconds. At 0933, 1610, kill time 2 seconds. Total engagement 14 minutes. Japanese losses 6 Zeros, 6 pilots. American losses 0 aircraft, 1 P-38 with minor damage to vertical stabilizer from 0 defensive fire. Kill ratio 6-0. The fuel consumed by P-38s in this engagement exceeded the weekly aviation fuel allocation for the entire Japanese garrison at Buna, which was operating under severe supply constraints due to American interdiction. Lieutenant Yamamoto presented analysis demonstrating that Japanese losses in November 1942 had increased 47% compared to October 1942, while American losses had decreased 23%. He calculated that if current trends continued, Japanese air strength in the South Pacific would be reduced to ineffectiveness within 6 months regardless of pilot skill or tactical innovations. His analysis noted that America was producing pilots at a rate of 2,500 monthly through expanded training programs, while Japan produced approximately 350 pilots monthly. The production disparity applied not just to aircraft, but to trained aviators. Yamamoto's report concluded, "We are losing a war of arithmetic. The mathematics are straightforward. They can replace losses faster than we can inflict them, while we cannot replace our losses at the rate they inflict them. This is not defeatism. This is mathematics." Command finally began to understand the scope of the problem in December 1942, when monthly loss reports showed 127 Japanese aircraft destroyed in the Solomon Islands sector compared to 34 American aircraft destroyed, a kill ratio of 3-7, one in favor of the Americans, a complete reversal of ratios that had prevailed 6 months earlier. Lieutenant Commander Saito, reviewing these figures, initially insisted they represented reporting errors or temporary setbacks. He stated in a December staff meeting, "Pilot quality remains superior. Equipment performance is adequate. These numbers reflect temporary difficulties in supply and logistics, not fundamental shifts in combat capability. Japanese pilots will adapt to the new American aircraft and restore proper kill ratios within 2 months." Lieutenant Koji Yamamoto, observing escalating losses and declining kill ratios, recognized that Japanese air power in the South Pacific was being systematically destroyed not through individual defeat, but through cumulative attrition that Japanese industry could not replace. His December intelligence summary stated, "The P-38 Lightning is not merely a superior aircraft. It represents American industrial capacity applied to warfare. Each P-38 destroyed is replaced within days. Each Zero destroyed represents a loss we cannot replace at equivalent rates. They are winning through production, not tactics." At Willow Run, River Rouge, and Burbank at Willow Run, Michigan, Ford Motor Company's bomber plant produced B-24 Liberators at a rate of 1 aircraft every 63 minutes by March 1943. Every hour, another 4-engine heavy bomber rolled off the assembly line. This single facility produced more heavy bombers monthly than the entire German aircraft industry, produced of all bomber types. The plant employed 42,000 workers, most with no previous aircraft manufacturing experience. They produced complex 4-engine aircraft using automotive assembly line techniques that aircraft manufacturers had claimed were impossible to apply to aircraft production. Charles Sorensen, Ford's production chief, had designed an assembly line 1 mile long where B-24 components moved continuously from raw materials to finished aircraft in a single flow. Japanese observers before the war had toured American automotive plants and reported that American mass production techniques could not be applied to aircraft, which required precision hand-fitting that American workers allegedly lacked the skill to perform. By 1943, American automotive plants were producing aircraft at rates that exceeded pre-war total global aircraft production. Americans discarded aluminum scrap from B-24 production, totaling 18,000 pounds daily. Japanese aircraft industry received aluminum allocations totaling 380,000 pounds monthly for all production. A single American bomber plant's daily scrap exceeded half of Japan's daily aluminum allocation to its entire aircraft industry. The discarded material included rejected forgings, trimmed sheet metal, defective castings, and components that failed quality inspection. In Japanese plants, such materials would be reworked regardless of the labor hours required. American plants found it more efficient to scrap defective components and produce replacements than to invest labor in rework. The cafeteria at Willow Run served 42,000 meals daily, consuming approximately 8,400 pounds of meat, 12,000 pounds of vegetables, 6,000 pounds of bread, and 4,200 gallons of milk daily. The food served in a single day to American war workers exceeded the weekly food allocation to the entire Japanese garrison at Rabaul, approximately 8,000 personnel subsisting on rice, fish, and limited vegetables. American workers consumed approximately 3,800 calories daily during high production periods. Japanese soldiers at forward bases received 2,100 calories daily when supply lines functioned normally, and less during interdiction periods. The waste from Willow Run's cafeteria, uneaten food, preparation scrap, and spoilage totaled approximately 920 pounds daily, which represented more calories than the daily ration for 600 Japanese soldiers. Workers threw away defective engine components that failed tolerance inspection at River Rouge Ford plant at a rate of 340 units daily. These included crankshafts, cylinder heads, connecting rods, and valve assemblies for aircraft engines that powered P-38s, B-24s, and other aircraft. Each defective component represented manufacturing precision that Japanese industry struggled to achieve even in accepted production. Japanese engine manufacturers worked to tolerances of 0.01 inches in most operations. American manufacturers routinely held tolerances of 0.001 inches and rejected components outside those specifications. The rejected American components, by Japanese standards, would have been acceptable for production use. The electrical power consumed at Burbank's Lockheed plant reached 4.8 megawatts by early 1943 as production expanded. This single facility's power consumption exceeded the total electrical generating capacity available to Japanese aircraft manufacturing in the Nagoya Industrial District, which housed Mitsubishi's primary production facilities. Japanese manufacturers operated under power rationing that limited equipment operation to specific hours and prioritized power allocation to military production over civilian needs. American manufacturers operated continuously, 24 hours daily, with power availability never constrained. Lockheed's parts inventory included safety stock of 14,000 propellers, maintained to ensure that propeller supply never limited aircraft production. Japanese manufacturers maintained propeller inventories of approximately 800 units and experienced chronic shortages that halted production. The American safety stock alone exceeded 17 months of Japanese propeller production. This pattern repeated across all components. American manufacturers maintained inventory buffers larger than Japanese total production. The waste from hydraulic fluid testing and system flushing at the Lockheed plant totaled 2,400 gallons weekly. This fluid, contaminated with metal particles and degradation products, was disposed of rather than reclaimed. Japanese aircraft maintenance units received hydraulic fluid allocations of 1,800 gallons monthly for all maintenance operations across approximately 200 aircraft at Rabaul. A single American factory's weekly waste in testing exceeded Japanese monthly allocation for combat operations. Training ammunition expended at American gunnery schools totaled 48 million rounds of .50 caliber monthly by early 1943. Japanese forces in the entire South Pacific Theater received approximately 31 million rounds monthly of all ammunition types, including 7.7, 13, and 20. American training expenditure exceeded Japanese combat allocation. This single aspect of American logistics training ammunition exceeded the entire Japanese ammunition supply to an entire theater of operations. Lieutenant Yamamoto, reviewing captured intelligence documents and reconnaissance photographs of American facilities, prepared an analysis that reached senior commanders in January 1943. His report stated, "American production capacity exceeds our estimates by factors of 3 to 8, depending on specific systems. The Lockheed facility produces 400 P-38 fighters monthly. Our entire industry produces 320 fighters monthly of all types. A single American automobile plant produces heavy bombers at rates exceeding our entire bomber production. They are operating a different kind of war, an industrial war where production capacity becomes the decisive weapon. We cannot win a war of production. The mathematics are absolute." April 18, 1943. Bougainville, Solomon Islands. Lieutenant Commander Sato was leading a fighter escort mission protecting Admiral Yamamoto's inspection tour when the engagement that would end Japanese air superiority in the South Pacific began. At 7:20 hours, Sato's formation of 18 Zeros departed Rabaul. At 9:34 hours, while approaching Balil Airfield, Sato observed P-38s attacking from high altitude, diving through the formation with speed that prevented effective counter-engagement. At 9:35 hours and 8 seconds, the first Zero in Sato's formation was destroyed. The P-38 dove through at approximately 400 miles per hour, fired a 2-second burst that struck the Zero's fuselage and wing root, and continued through without attempting to maneuver. The Zero exploded. Elapsed time from engagement to destruction, 17 seconds. Kill time, 2 seconds. At 9:35 hours and 41 seconds, 2 more Zeros were destroyed by P-38s employing identical tactics. High-speed diving passes with concentrated fire, no maneuvering, immediate disengagement after firing. Kill time per aircraft, under 3 seconds. The P-38's concentrated armament of 4.50 caliber machine guns and 120 cannon, all mounted in the nose and firing through the propeller arc without synchronization, created a cone of fire that required minimal time on target to achieve kills. At 9:36 hours and 23 seconds, Sato attempted to lead a counterattack against P-38s that had completed their initial pass and were climbing away. His Zero could not match the P-38's climb rate. At maximum power, the Zero climbed at 2,900 feet per minute at sea level, but performance degraded rapidly with altitude. The P-38, with turbochargers maintaining engine power, climbed at 2,850 feet per minute at sea level, and maintained nearly constant climb rate to 30,000 feet. Sato's attempt to pursue resulted in his formation being caught in a slow climb by additional P-38s diving from above. At 9:37 hours and 11 seconds, Sato's wingman was destroyed by a diving P-38. Elapsed time, 34 seconds. Kill time, 1 second. At 9:37 hours and 58 seconds, another Zero was destroyed in the same manner. At 9:38 hours and 21 seconds, a third Zero fell. At 9:38 hours and 47 seconds, a fourth. At 9:39 hours and 12 seconds, Lieutenant Commander Sato's Zero was hit. A P-38 had positioned above him, rolled inverted, pulled through to establish a 45-degree diving attack angle, opened fire at 500 yards, and maintained fire through 300 yards. Sato felt impacts along his aircraft's spine. His canopy shattered. The control stick went slack as hydraulic lines were severed. His Zero rolled right and entered an uncontrolled spin. At 9:39 hours and 28 seconds, Sato's aircraft struck the ocean surface at approximately 280 miles per hour. He did not eject. The Zero possessed no ejection seat. Sato was killed on impact. Elapsed time from initial engagement of his specific aircraft to his death, 16 seconds. Total elapsed time from beginning of engagement to Sato's death, 4 minutes 20 seconds. The engagement continued without Sato. At 9:41 hours, 3 more Zeros were destroyed. At 9:43 hours, 2 more fell. At 9:45 hours, the surviving Zeros, now reduced to 6 from 18, fled toward Rabaul. The P-38s did not pursue. They had accomplished their primary mission, intercepting and destroying Admiral Yamamoto's aircraft. Total Japanese losses from the escort mission: 12 Zeros destroyed, 12 pilots killed. American losses: 1 P-38 with minor damage, pilot returned safely to base. Kill ratio: 12, 1 in favor of American aircraft. The engagement had been systematic annihilation. The ammunition expended in this 14-minute engagement exceeded the monthly ammunition allocation for 3 Japanese air bases. This wasn't combat in the traditional sense that Saito would have recognized. This was industrial warfare where superior production, superior logistics, and adequate, not exceptional, merely adequate tactics produced systematic destruction. The P-38 pilots involved in this engagement averaged 340 flight hours each, less than Japanese pilot training standards. They won through equipment advantage, not superior skill. Commander Nakamura, who had survived because he had been assigned to a different mission that day, received the news of Sato's death while at Rabaul. His reaction, recorded by Lieutenant Yamamoto, who was present, consisted of a long silence followed by the statement, "The war is over. We simply haven't admitted it yet." May 1943. Prisoner of War Interrogation Center, Brisbane, Australia. Lieutenant Koji Yamamoto had been captured when his reconnaissance aircraft was forced to ditch after being damaged by Australian Beaufighters over New Guinea. Interrogators found him remarkably willing to provide analysis, not from any lack of loyalty, but from a resigned acknowledgement that the information he possessed would change nothing about war's outcome. "We were not defeated by better soldiers, but by better factories," Yamamoto stated in his interrogation of May 23, 1943. I reviewed production figures throughout 1942 and early 1943. In January 1942, America produced 1,580 military aircraft. Japan produced 740. By January 1943, America produced 5,920 aircraft. Japan produced 1,180. A single American factory, the Lockheed plant at Burbank, produced more fighters monthly than our entire industry. Your Ford plant at Willow Run produced more heavy bombers than our entire industry produced of all bomber types. This is not a comparison of similar industries at different scales. This is a comparison of an industrial economy against a pre-industrial economy attempting to compete in industrial warfare. Interrogators asked Yamamoto about Japanese pilot quality and combat effectiveness. He responded, "Pilot quality became irrelevant in the face of production disparity. Our best pilots shot down American aircraft at favorable ratios in early engagements. But you replaced aircraft within days. We required months. You lost 20 aircraft and received 40 replacements. We lost 20 aircraft and received 8 replacements. The mathematics are inescapable. Additionally, your pilot training production exceeded ours by similar ratios. You graduated 2,500 pilots monthly by late 1942. We graduated 350. You could lose pilots at terrible rates and still increase your combat strength. We maintained high training standards but could not produce sufficient numbers." Commander Nakamura, interrogated after his capture in July 1943, when his Zero was shot down by P-38s during a futile defense of Rendova, provided additional perspective. "I saw the P-38 enter combat in November 1942. I immediately recognized that we faced equipment beyond our capacity to counter. The aircraft was faster, climbed better, possessed heavier armament, and could absorb damage that would destroy a Zero. But the real shock came when I learned production numbers. We destroyed P-38s in combat and congratulated ourselves on successful missions. Then we discovered that the Americans had replaced those losses and added additional aircraft beyond replacements. We were like men emptying the ocean with buckets while the tide rises." Nakamura continued, "They didn't just outproduce us. They revolutionized production itself. Your factories operated like I had never imagined manufacturing could operate. Workers with minimal training produced complex systems with precision that required master craftsmen in Japanese industry. You achieved this through design components designed for rapid assembly rather than hand-fitting, tolerant specifications that allowed interchangeable parts, manufacturing processes that incorporated quality control rather than relying on post-production inspection. Japanese industry produced aircraft as craft items. American industry produced aircraft as industrial products." Additional testimonies from captured Japanese officers provided consistent themes. Captain Hiroshi Tanaka, air operations officer captured at Mundo in August 1943, stated, "We brought swords to a war fought with industrial production lines. Our pilots were samurai-facing factory workers equipped with superior tools. Individual quality cannot overcome systematic industrial advantage." Lieutenant Masao Saito, nephew of the deceased Lieutenant Commander Saito, captured in September 1943, stated, "Your excess capacity exceeded our maximum effort. We operated at absolute limits of our industrial capability, stripped civilian economy, prioritized military production above all other needs, and still produced less than single American factories operating at routine capacity. The war was decided not by battles but by production figures. Captain Toshiro Yamada, logistics officer for the 11th Air Fleet, captured when Rabaul's position became untenable, stated, "They could lose aircraft at rates that would have destroyed Japanese air power and consider those losses acceptable because production exceeded losses by comfortable margins. We calculated replacement rates and recognized that America could sustain losses of 600 aircraft monthly in our theater alone and still increase combat strength. We could not sustain losses of 100 aircraft monthly and maintain strength. The mathematics were, as Lieutenant Yamamoto always said, absolute. American production of P-38 Lightning fighters from program inception through war's end totaled 10,037 aircraft. Japanese production of Zero fighters for the same period totaled 10,939 aircraft, nominally similar numbers. However, Japanese production represented the entire focus of Japanese naval fighter production from a nation operating at maximum industrial mobilization. American P-38 production represented one fighter type among many. America also produced 12,571 P-47 Thunderbolts, 15,686 P-51 Mustangs, 7,825 F-6F Hellcats, 12,571 F-4U Corsairs, and numerous other fighter types. Single American fighter programs exceeded total Japanese fighter production. The entire American fighter production exceeded Japanese total aircraft production by a factor of approximately 8-1. Total American aircraft production 1941-1945, 303,717 aircraft. Total Japanese aircraft production 1941-1945, 76,320 aircraft. A 4-1 advantage that represented not superior effort but superior industrial capacity. Japanese industry operated at capacity limits. American industry operated at comfortable production rates while simultaneously producing ships, tanks, trucks, weapons, ammunition, and consumer goods. The United States produced military equipment, supplied allies, and maintained rising civilian living standards. Japan produced military equipment and experienced declining civilian conditions, including food rationing, clothing shortages, and fuel restrictions. The P-38 Lightning, the aircraft that Japanese pilots were shocked to encounter in the Solomons in late 1942, exemplified the lesson of industrial warfare. It was not the world's best fighter. It had limitations including poor roll rate, complex maintenance requirements, and vulnerability to cooling system damage. But it was produced in overwhelming numbers, supported by logistics that ensured spare parts and ammunition availability, flown by adequately trained pilots who were rapidly replaced when lost, and employed in tactical doctrines that emphasized its strengths while minimizing its weaknesses. Japanese forces faced not a superior military, but a superior industrial system applied to warfare. The democratic production advantage the P-38 Lightning proved that democratic industrial economies possess structural advantages over authoritarian command economies when mobilized for sustained production. Free workers outproduced slave or coerced labor because they possessed initiative to suggest improvements, motivation to maintain quality, and flexibility to adapt processes. American factory workers proposed manufacturing modifications that reduced production time, improved quality, and increased output. Japanese workers operated under rigid hierarchies where process modifications required extensive approval and were rarely implemented. Dorothy Miller's tooling suggestion that saved 30 seconds per component represented a microcosm of systematic advantage. Distributed intelligence of thousands of workers, constantly optimizing production versus centralized control that stifled worker initiative. Democratic cooperation exceeded totalitarian command because American industry integrated civilian expertise into war production through voluntary cooperation rather than forced compliance. Dollar-a-year men brought corporate expertise to government production management without requiring coercion. Workers accepted wage controls and overtime requirements because they understood the necessity rather than because they feared punishment. Unions collaborated with management to maximize production rather than requiring suppression. The result was voluntary efficiency that exceeded coerced effort. Industrial abundance buried ideological claims of superiority under the literal weight of production output measured in millions of tons. Japanese military ideology claimed spiritual superiority would overcome material disadvantage. American production proved that adequate spirit combined with overwhelming material creates undefeatable force. The mathematics were absolute. Production advantage of 4-to-1 combined with adequate tactical competence produces victory regardless of enemy determination. October 15, 1942. Lieutenant Commander Sato had laughed at American twin-engine fighters, dismissing them as desperate improvisation. April 18, 1943. Sato died when a P-38 destroyed his Zero in 16 seconds. His mockery became history's most expensive miscalculation, measured in 10,000 Japanese pilots dead, air superiority lost, island chains reconquered, and a war decided not by courage but by factory production. The lesson remains. Dismissing democratic nations as weak because they prefer peace or underestimating free people's productive capacity when mobilized invites catastrophic miscalculation. The United States in 1941 appeared unprepared, its military small, its industrial capacity focused on civilian goods, its population unmobilized. But that civilian industrial capacity, when redirected to military production, generated overwhelming force. The Japanese officers laughing in Rabaul headquarters in October 1942 could not imagine that American automobile factories would produce bombers, that civilian workers would build fighters, that democratic voluntarism would exceed totalitarian control. Their failure of imagination cost them everything. The P-38 Lightning, arriving in the Solomons in late 1942, announced that American industrial power had arrived in the Pacific. Japanese pilots were indeed shocked. The shock was fatal,